I'm Kurt Nelson, and I don't have where I work on this slide because I just started at Uber last Monday. I was, however, at Google for 3 years and was kind of sitting in the eaves watching Jetpack get built. And so I'm here to kind of share some stories about why Jetpack exists, and then kind of go over an overview of the various components, what they're good for, when you should use them, and when you should not use them. So I always start my talks by lifting stuff off of the official Android documentation. And here, this is straight from the little header at the top of the Jetpack page. And Jetpack is a collection of Android software components to make it easier for you to develop great Android apps. These components help you. It's too many words. My summary is Jetpack is a collection of Android software components. That is what the most important part is it's just a collection of libraries. It's not necessarily one big unit. It's a bunch of different dependencies that you can pull in to then do all the other stuff that that phrase talks about. Further down, there is a little section here, and this is the other important part, is that Jetpack is really kind of a rename of some existing stuff plus some new stuff. So everything under androidx.star is part of Jetpack. And historically, that contained a bunch of different things, but now it's all in one home. These dependencies are also now all available via Gradle and Maven, so that you can stay up to date and not be coupled to Android OS platform releases. So my opinion is that I lost the slide. There we go. So yes, you should use Jetpack. But let's talk about what would happen if we, went into Android Studio, went to File New, created a brand new project. What would happen? So if I'm a brand new developer developing an Android app, I know Java, I know what I'm doing. Android is Java, is what they say. So let's use that auto code gen in Android Studio, go file a new project, and see what happens. Well, it generates a bunch of different stuff, but what I care about for the purpose of this talk is this is all that you end up with in your build.gradle, your dependencies for your app, is you end up with 5 things. And these really don't help you all that much, especially if you're a brand new Android dev. You're like, okay, app compat, I want my app to be compat with things, sure. Constraint layout's really cool. And then testing stuff. But this doesn't really help you with a lot of the more important things in your app, in my opinion, such as, well, what's the best way to get data into the UI? If I want to load an image, how do I load an image? If I want to move between screens in the app, switch between fragments, activities, should I use fragments? Should I use activities? What should I do? And then if you're wanting to support newer things like Android O, which you have to actually as of, I guess, nowish, if you're doing a new app, you have to worry about this whole background check thing. And if I'm just a new Java dev coming over from backend development or maybe even iOS, I don't have an obvious, or for a long time, you didn't have an obvious way to solve these problems. So that's true for brand new developers, for brand new to Android, but also if you are maybe coming in for your first job onto an existing code base as a new Android dev, or even switching jobs to a new app, everybody kind of has historically chosen their own path forward on how to do these things. Like, do you use futures? Do you use RxJava? What image loading library do you use? Do you use Glide? Do you use Picasso? And there's not really one standard way that people tend to build Android apps. Not that that's a bad thing, but if you're moving around between projects, especially if you're at a consultancy, for example, you might be having to kind of rethink this every app. So the general solution to this type of problem in software is to have an opinionated framework. I actually originally started writing Ruby on Rails apps. And in Ruby on Rails, everything is very opinionated. There is a correct way to do it, and then there are other ways to do it. And if you do it the correct way, everybody's going to be happier generally. It's a good idea to do it that way, unless you have a pressing technical need to do it differently. On Rails, if you want to do databases, you write migrations. That way, a new person coming to your app can start up the app on their local machine and knows how to set up the database. Well, Android and mobile is a little different. There's a lot, I would say, a lot wider types of apps, whereas like a backend app generally is going to be responding to requests and serving URLs. Android app could be anything from a similar thing where it's just pages of documents. It could be a game. But let's say we at a company are going to make a lot of semi-similar apps that are consumer-facing apps. So at Google, we built our own opinionated framework. Now, this framework came out of the Google Plus/social product area days. And so we can make all the jokes we want about Google Plus, as we should, but something useful did come out of it. We built an Android framework, and it was called TikTok. And now the problem with this framework, and the reason we never open sourced it, is it is very heavily coupled to Google-specific build tooling. If you've heard of the Google 3 monorepo, there's some public blog posts from ex-Google people about that whole thing, but it depended on being in a monorepo. And then it also required a lot of visibility restrictions. We were able to, in our repository, take certain build targets in there. So think like Gradle modules, or if you've used Bazel, it's going to be build targets. We could restrict access to those so that if someone wanted to take a dependency on us, they would have to actually send it to us for code review, and we'd have to see how they're using it before they could start using it. So a lot of this stuff we had in there is actually very similar to Jetpack, and some of the Jetpack libraries are kind of inspired by our code, and some of our code was inspired by the early Jetpack stuff. But this was really nice, but it was very Google specific. We also were able to then have a tech writer come in and build out tons of guides for us for internal usage of this framework. And actually that tech writer is also, if you've read any of the Big Nerd Ranch books, she also actually edits those. So she's been doing this for a very long time and was very good at technical writing. So, okay, that's what we did at Google, but Google's weird. We don't even use, I've still never written any Kotlin, and I hadn't used Gradle in like 2.5 years until last week. So, okay, we're not at Google. What can we do? Well, if you're at a large tech company, you can probably kind of do the same thing. You can have a framework team or a platform team or whatever you want to call it. Could be even like one person. It could be a huge team. And these are the people that are kind of your internal consultants or your internal experts. If you want to bring in some new external dependency, you'd probably come run it by these people and be like, hey, we want to use Glide to load these images. Is that okay? And they might say, oh, well, actually, this other team's already using Picasso. That's already shipping in the binary, so you should also use it so that we don't have two different image loading solutions. These people can maybe help with code review, especially if you have a dispute on how the best way to do something on mobile is. The other nice thing that we actually spent a large portion of our time is on testing infrastructure. Our job was to make it so that if you were using the list of dependencies that we said we were okay with, you could actually write deterministic, non-flaky tests. UI tests, screenshot tests, everything. But we had to spend a ton of effort on anytime we pulled in a library, making wrappers and shims to kind of work around issues in external libraries. But when we had a couple hundred different developers all using our framework, it was worth our time to make testing easy. This framework team also just hopefully has the weird Android knowledge of like, oh, on this API version, this was broken because if you hold it this way wrong, you'll crash the phone. A lot of weird stuff like that, or the old Samsung bugs, knowing like, oh, if you try and hide the keyboard on this device, it's not going to work, but if you do this magic incantation, it will work. And so having a team that knows that stuff and can hopefully even wrap some of that knowledge in a library itself to handle these things for you. Okay, so that's nice if you're a big tech company. This is how it works at Uber. There is, I think, about 6 of us directly committed to frameworks along with a lot of build tooling help. A bunch of people own build tooling. But you probably aren't, most of you probably are not all at big tech companies. The Android ecosystem is very diverse now. So kind of, this is what I used to do in my old job, is like be like, okay, let me Google around, look at Stack Overflow. Okay, oh, Jake Warden said that's good, I might use that. Thank you for coming to my talk right now and not his, by the way. Thank you. So you'll go Stack Overflow, look around, be like, oh, some Google DevRel people said this is nice on Twitter once. Let me try it and use it and hope it works. And then you ship it and it mostly works, but you have these weird crashes on certain old devices in China or somewhere weird. And it's really not exactly a fun way of building apps. So Jetpack is kind of a nice step forward in this direction of, it's not a framework, it's not an opinionated framework, but it is a set of libraries that all work nicely together, and if you use, you're going to actually be supported. So I put this in quotes. Jetpack is a right way to build apps. You can build an app using Jetpack, and it will probably work pretty well. It's not necessarily the best way to build apps, but it's a good place to start. So most important part is that Google is standing behind these libraries now. So you can go file an issue in the bug tracker. You can tag it with, I forget what it is, but you can tag it right on Stack Overflow, and someone will probably come by and see it. And then also Room and List and Live Data and all those, they all use each other in a way that makes sense and is pleasant. Now, as I say, it's a right way. It's maybe not the best way. So, for example, the one I like to use most here is Live Data versus RxJava. If you are already using RxJava or have used it in the past, and your team has knowledge around best practices, stay with it. Like, there's no reason to switch to Live Data from Rx. If you haven't done Rx before, Live Data is a really nice spot to start. It's a more simplified model that is not as powerful, but is even easier to use. Data binding, I don't like data binding. My old team really hated data binding because at one point it used reflection, so it made pro-guarding hard. But hey, if you like data binding, use it. Download Manager, which is part of Jetpack, even though it's really been deep in the OS for a long time, there's actually certain API levels where it's susceptible to some various security issues that you can go dig into. But so if you're downloading something, Download Manager might be good, but you might care about security. I don't know. The navigation library I really like. If your app hits a certain size, though, for now, navigation may not work as well because it tightly couples the build system, and you might have instant apps and stuff. I think Daniel and them are talking about that actually next, where they're going to talk about some ways of splitting your app with navigation. It's a good spot to start. And also, the other problem with navigation is that if you are not using fragments or activities, it's kind of useless. But good place to start once again. So my takeaway, if you have one takeaway from this talk, it should be use Jetpack until it doesn't fit your needs. Start with it, grab one off the shelf if you think you need it, try it out, keep using it, and then move to something later if you need to. So let's talk about this other weird part of Jetpack, and that is Jetifier, which is kind of just a rename. Basically, to start with, everything that was in android.support.package name is now somewhere under androidx. So for now, this really is basically a rename, and Jetifier is a tool that will reach into dependencies you were using and rename it for you until they've released a new artifact themselves. It's a pain to turn on. It's broken for people at Google. It's broken for people outside of Google. We're kind of in a transitionary stage here. But the idea here is that stuff that has historically been very tightly coupled to the operating system can start moving into your applications. And this has a bunch of different advantages. One of which is that I know the OS frameworks the OS fragments are finally being deprecated, and you're going to be only wanting to use fragment from the androidx namespace. The operating system fragments have had a different set of bugs than the support fragments for years, plus then you had to deal with platform fragmentation. Going forward, if you just use fragment from androidx, you have one version, you hopefully have the same version as everybody else. We can kind of all move together instead of having to worry about the last 6 years of Android bugs. Other libraries can now kind of use things from androidx without really making downstream dependencies mad. So there is a androidx core dependency that has a lot of the common glue classes. And so that's one that I think any dependency should be able to pull in and nobody should get upset about. But also, if you are writing a library and it needs to queue up background work, you can depend on Work Manager and likely not cause a binary size increase because the app is likely using it too. Then further down the road, views can start getting decoupled from the OS. So there's no good reason for Vue, the actual class called Vue, to be in the OS. Really, all you need as an app is a canvas to render on. Everything else can be handled inside of your APK. And if we go way down the road, probably will take forever because Android moves slow because of the amount of long tail of old versions out there in the wild, we might be able to move to where there are some shared libraries across apps on the phone for views or constraint layout, for example, that allow you to make your APKs smaller if you use these common sets of tools. That's kind of a pipe dream at this point, but this is a first step. So right now with Jetfire, if you turn it on, I know for a fact it breaks Glide completely right now. I have a bug filed on myself for that one. And some other third-party libraries definitely break. Any library who's doing CodeGen is probably broken because they are likely calling android.support. Some sort of annotation or generated code, and they need to detect if Jetfire is turned on and emit the new names instead of the old names. Google's going through this pain and suffering too on the monorepo, which is a whole nother ordeal. So I think this is going to shake out. Hopefully by the end of the year, we're just in this transitionary period where we're renaming hundreds of classes, and some people haven't gone into it yet. So that's my little summary of Jetfire. If really a lot of the Jetfire problems you'll run into are going to be kind of nitty-gritty and best answered on somewhere like Stack Overflow because you're going to have this class can't be found, and you're going to have those types of errors. So now let's do a very quick overview of the components and kind of my opinions on them. These are very much my opinions. So navigation, I put this first because I like it. So if we go to the Android docs, way in the moving between activities 101 section, this is how they still say to do it. Instantiate an intent with a direct reference to the activity, stuff an extra in it, and call activity. Now this code is normally in the starting activity. So here, let's say we're in main activity and we want to go to display message activity. This code would live in main activity. Now this is really never ideal, and I don't generally see people doing this still. I generally see them doing it this way, where the target activity has a method for building the intent on it. And actually, that's missing a static. And this allows you to not have other activities having to know about the guts of a different activity. Here, you're never going to forget the extra because it's a required parameter, and you can use the compiler to keep you from forgetting things. So this is nice. This is the way I've been doing it forever. But, I mean, you still have to do extras, and it can get a little gross, especially if you need to go to a specific fragment inside of an activity. So here is the navigation library, some XML example. This is way more text, but really there's maybe 5 lines that are interesting here, and those are the 2 actions. And so this is a very structured way of defining your navigation graph. You also can, in these actions and these fragments, add parameters and required arguments in here, and it will code gen for you a method that has the right types on it, parcels it for you across IPC. It makes it really kind of fail-safe. And so you write that XML once, and then if I want to move between activities, I just do this one call with a very explicit ID number of where I want to go. And especially if you have new people onboarding into an app, and they're like, how do I get from this activity to that activity? They can go look at the XML, find the activity, look at where you can go from there, and then make those action calls. So I have not seen a popular library that does something like this, so that's where I think this is really beneficial, is this is kind of the first one to do this. A lot of people, especially on bigger apps, there's that one person who owns getting between activities, and you're like, hey, I need to get to this fragment deep inside this other fragment. And then they're like, oh, well, that's going to be a pain. talk to me in 2 days after I untangle this dependency mess. If you are using fragments, this is really nice. If you are not using tons of fragments, but just activities, it's still helpful. And if you're doing a single activity app, well, you're kind of on your own still for navigation, but you probably are using some whole different model. Navigation, if you have two parts of an app that are very separate and you want to be able to build independently without having to compile both at the same time, you may not want to glue those together with navigation. You might just want to use a text string and a plain old intent so that the compiler doesn't have to touch both sides of the app. My next favorite one is Work Manager. This is, in my opinion, the best part of Jetpack because this stuff has changed super rapidly over the last 2 or 3 years. With you have Firebase Firebase, whatever it's called. Firebase is one, Job Scheduler, and Alarm Manager, and then there's also 3 or 4 different open source libraries that try and do the same thing and are some subset of it. With background check, most apps, if you want to guarantee that network actions complete, are going to need to use something like Work Manager. If you are doing an action that mutates state on the server, for example, a chat app, when the user hits send, you want that message to go through, so you should be using Job Scheduler, Work Manager, or Alarm Manager. You should be using one of these things. Work Manager is really easy. You call workmanager.init when your app starts, and then you declare these job classes with a very nice declarative API. The other nice thing that I'm really looking forward to with Work Manager is there's now a standard that we should all be able to agree on. So if you are writing a library that needs to do deferred work, you can also use Work Manager and not pay any extra overhead. A lot of libraries have been pulling in, there's the Evernote library, there's the Firebase one. If you're using a bunch of libraries, you might end up pulling 4 different things, 4 different deferred work managers. But now that we have an official one, we can hopefully all agree that it is the path forward. Then we have Room. So I, for one, have been used to just writing SQL for years because I did backend. So I somehow became the SQLite Open Helper guy on my old team. And SQLite Open Helper is kind of hard to use, especially if you want to use it asynchronously with futures or live data. It's really easy to leak memory. It's a pain to close the database at the right time. There's a ton of concurrency issues. If you want to be able to truly use it in an asynchronous manner, you have to manage a ton of stuff. Also, then you have to write your own migrations with just pure text SQL, and all your queries are just plain dumb text. Now, Square has SQLite / SQLDelight, which is kind of a step above SQLite Open Helper. SQLite gives you an async API, and then SQLDelight manages some of your schema and SQL statements on top of that. But that still requires you to kind of be pretty familiar with SQL and SQLite and all that. If you're new to Android or new to programming, this is way more complexity than you probably need for your first app. And Room handles this really nicely for you. It is basically like, hey, I have this Java object and I want to save it. Go save it for me. You don't have to necessarily think about joining across tables or anything of that nature. It does go very far in this direction of doing the data access object interface. And so if you need to have more complex joins or care about certain performance cases, you probably should go back to using one of the other systems. But to start with for your app, for just storing and retrieving data, Room is excellent. One thing that still has not kind of been figured out yet is how much of an effect Room can have as far as binary size if your app gets big, because it's storing POJOs and Java objects, and you have to do all these interfaces for every table in your database. You might end up just having a ton of model code that is all kind of just mapping between maybe JSON and Java. So if you have a large app, you might want to double check that you aren't going to just balloon your APK size a bunch by using Room. But if you're a new app, go for it. Next is View Model. This is essentially better loaders. And loaders it's not hard to get better than loaders. They're pretty hard to use right now. And there's some code for how to get some objects out of the view model. I have personally not used view models. We had our own custom retained fragment-based implementation, but they're there. If you find yourself reaching for loaders, maybe you should look at view model and see if it fits the use case. Then we have lifecycle. So lifecycle is nice. I, once again, haven't used it a bunch because I haven't had a need to, but it allows you to make any object aware of the activity/fragment lifecycle. So this allows you to kind of decompose or break up your big activity classes in a lot of cases, or if you have common code that you have to, like an analytics library maybe, where you're constantly doing things in onCreate and onDestroy, you can break that out into a different object and use lifecycles to just say, hey, analytics library, here's an activity, do what you want with it. And also, with OS fragments going away, you'll be able to assume that if fragments are being used, they are support fragments, meaning that they fully support lifecycle components. So if you're a library, you should just get rid of support for OS fragments, essentially. Live data, I already mentioned earlier. This is one I asked a bunch of people about and got a wide variety of answers. Some people said, oh yeah, we use live data the whole way. The other common answer I got was, we use live data only in our views, but we use RX in our models. And we have a layer that converts RX to live data because we found live data is easier for people writing view code to wrap their head around. If you're comfortable with RX and already using it, probably just stick with that. It's pretty standard in the community these days. It's not really a surprise if you're using RX. If you're starting a new app, I don't know. This is one that I would like to explore more and see where it can go. So there's two things that I still really would like to have in Jetpack and probably won't happen. But I know right now in the Google documentation, they kind of officially bless Glide and Picasso as the image loading libraries of choice. I'd like to just get super opinionated and just pick Glide, because Glide is, even though it's not in the Google repos, the guy who created it works at Google now. So Google has control over it, and we were able to keep it up to date for Android P, for example. When P was still not open source, we were able to keep Glide fully compatible. And also, if everybody settled on one image loading library, that would be nice for binary size, that, once again, if you depend on somebody else and they pull in Picasso but you use Glide, you're just adding unnecessary bytecode. And then I really want keyboard compat, but that's a pipe dream. That's never going to happen, because I've been wanting that for like 4 years. Anytime I have to hide the soft keyboard across all devices in a reliable manner, I just get sad and want to go write iOS. So I know this is a very quick overview of all these things, but that's because there are all these great talks happening on these things. Adventures in Navigation, I know that is in the next slot, or in the next time slot. I don't know which room it's in. There is one on emoji, and I actually didn't mention emoji compat at all, because as you can tell by my slide deck, I'm definitely a colorful emoji person. Then there is an architecting an app with MVP and view models, which I think I will actually go to hear about view models. Then Firebase and Arc components, they do work really nice together, especially if you're using the Firebase real-time database. You can just use live data the whole way and not really have to think about a lot of things. Then there is a nice overview of Alarm Manager to Work Manager. As I said, that is a space that has kind of ballooned in complexity in the last 2 years or so, and hopefully now we can all sit down and agree that Work Manager is the right way to go. And then Picasso 3.0, which is not out yet. I know it's being actively developed. And Picasso 3 is going to handle some of the changes that happened in P with where bitmap memory is allocated. I know in Glide, I actually updated Glide so that there's bitmaps have been stored in 3 different types of memory over time historically. So depending on which API version you're on, it's either native in the heap or it went back to native again. So Picasso is going to be updating, and I know they're going to be dropping a lot of kind of legacy code. a lot of this stuff, architecture component stuff, if your min SDK is 16, you're good to go to use it all. Yeah. And then there's a link to these slides, which I'll push a slightly updated version of in a little bit. So, any questions? No? Okay, cool. Thank you all.